What's up, Bryan? How's it going?
Hi.
Yeah, Bryan and I both work on InferenceMAX, or it's called InferenceX. All right, because we got sued by HBO Max. Just kidding, that's a joke. But yeah, I guess like let's just kind of talk through like what it is and like what we've been working on and kind of its influence. I guess today, you kind of saw Jensen go and talk about it and declare himself the Inference King. I guess what does it mean to you to kind of be the Inference King and like have the highest throughput chip? Like what do you think is important about that in like today's kind
I
of
mean, yeah, Jensen's probably pretty proud. Across all of our benchmarks, NVIDIA chips like get the highest scores, the lowest cost for per token, etc. So it's really uh the king of inference, I guess.
I guess like why do you think that I think a lot of people, right, like on X and stuff say, "Oh, well, like Dylan and SemiAnalysis are just like, kind of like praising NVIDIA." But like explain to people how this is truly like an independent third-party benchmark and it's not like other suites where like we have like rules and stuff and people can hill climb. Like kind of explain your thoughts on that.
Yeah, so I guess the biggest part that is that we are open source. I mean, if there are people who think that AMD can do better, they can feel free to just submit runs or submit configs to our configs and we can run it for them. But so far, all the data has been showing that NVIDIA does, in fact, surpass AMD in almost all aspects.
Yeah.
And
Yeah, I think that's a good point. Like the idea of Inference X is sort of to provide a benchmark such that when people are hill climbing it, it's making the entire like ML community
yeah,
better and more efficient and stuff. So yeah, like I'd say like to add to your point, right? It's completely open source and anyone is welcome to kind of like contribute to it and just make the entire ecosystem better. So yeah, we always want to be like really transparent about that. But yeah, I think that makes it even more like prominent when a chip provider can be like, yeah, we have the fastest chip.
yeah.
Yeah.
I want to know more about like what's we like working with AMD and NVIDIA because like you've been here longer than me. So how's the experience actually?
Yeah, actually, it's been really good, and like InferenceX would not be possible without their engineers. Like they do a lot of the tuning of the configs and stuff. And yeah, I think it's been really a joy to work with a lot of them. And yeah, it's been really great. I guess we can talk about so like what do you think about the LPU stuff, right? Because that's like kind of like a
Yeah.
hot topic right now, and like it directly kind of ties into like the Pareto frontier of that we show on InferenceX. Like, what are your thoughts on that, just in general?
Oh yeah, Jensen did just announce that earlier, I guess. I mean, NVIDIA does knows the most about its customers. Like, of course, the customers will directly ask NVIDIA for stuff that will improve their inference performance. So I guess in a way, disaggregated inference is the future, and to really optimize the each specific part of disaggregated inference is that this LPU does in fact uh, surpass GPU in some aspects, and that's why NVIDIA developed it, already acquired Grok, and used it instead.
Yeah, yeah, I think it's really interesting that instead of just like using the grok rack to do inference like across the whole curve, they're really just leaning into the strengths of grok and just saying like, okay, well, it can do really fast high interactivity, and we're just gonna do that like co-packaged with the Rubin system. And like, I wonder if like, do you think we'll see that from other alternative chips like MATX and others, or do you think will this be a continuing trend?
I mean,
Maybe not with NVIDIA
yeah,
specifically, but
I mean, it'd be interesting to see. There are theories that like Amazon is using NVL72 along with their own chips for
right,
disaggregated inference.
right.
Like, there's really a lot of space to optimize each part, especially since it is disaggregated.
Yeah, yeah, I agree. And especially with like new architectures, like obviously mixture of X isn't new, but as we see new architectures, right? Like I think inference really like Jensen was talking about today, there's a lot of opportunity for optimizations and like you can really disaggregate a lot of the inference parts. So I think I'm really excited to see like what comes up and what we can actually showcase on Inference X, right?
Yeah,
Uh really I hope we can get like some alternative chip providers on
of
there, right?
course, of course.
Uh,
Yeah, and the trend is towards, I guess, towards like everyone's trying to develop their own chips. Uh, OpenAI has their a titan in development. And some other trends are also like regarding the model specs. We are seeing MOE models being more sparser with smaller experts. And of course, this plays into YEP. So it's quite interesting to see that the researchers who are planning model architectures actually care more about inference optimizations. I used to think this was only a DeepSeek thing, like only DeepSeek really cared about these inference optimizations. But yeah, it seems like inference performance is getting more and more important and is being considered along with the models like actual performance.
Right.
Okay, so tell me what plans you have for InferenceMAX.
Yeah, that's
V3.
that's a good question. So yeah, right now, with InferenceX, right, we're using random data
Yep.
for all of our benchmarks, which is actually quite good for a baseline benchmark, right? So when you think about it, the way I like to explain it is, in a way, right now the benchmarks are kind of showing like the worst the chips will actually perform, right? Because it's just a baseline. There's no prefix caching, because we don't do multi-turn data sets. It's all random. And then speculative decoding acceptance rates are quite low because it's the random data. But for InferenceX v3, we want to add agentic benchmarks, like really good, like a representative multi-turn QA chat benchmarks where there are a ton of client sessions, each with multiple turns, and will enable prefix caching. And like, to your point, right, like NVIDIA is beating AMD across the whole curve, like you said, or most parts, but like AMD MI355X versus B200, MI355 has 1.5 times the HBM band capacity. So with prefix caching, right, like we'd expect it to do better, possibly. So I think it will help showcase the chips from a more
Objective.
nuanced, I was gonna say, like, perspective, right, and like capturing all of the parts of each chip. But yeah, I think actually making a good agentic benchmark is something that we're realizing is quite difficult and something that hasn't really been done publicly yet. So that's a lot of work, but yeah.
Oh, yeah. And I've heard like during GTC after parties or like events, I've been speaking to people, and it seems like KV cache offloading and KV cache, these kind of strategies are getting more and more popular.
Yeah. KB cache offloading is something we've been investigating a lot. Like vLLM just basically in vLLM 0.16, I think they made it native KV cache offloading. You have things like LM cache, distributed offloading, like with LLMD and stuff. And I think, we were talking to a lot of people at the hackathon the other day, like
Yep.
doing this as like their project and stuff. And yeah, I think, I mean, at the end of the day, when you want long context inference, you need a big KV cache, and you also need that to be extremely fast. So there's not really enough room just in HBM. You need to offload it somewhere. So yeah, I mean, I don't know. Like, what do you think about this topic? Like, do you think like basically the future is just going to be like how fast we can offload KV cache and how much we can offload, or do you think it's bigger HBM, or what do you think?
I mean, I'm very interested. To be honest, I'm very interested to see what the frontier labs are actually doing. But I mean, no one knows, and open source is probably behind those labs by like half a year, maybe at best. Yeah, but
Yeah, I mean, that's a good point, because like Opus 4.6, 1 million context is the default now, right?
yeah,
So like, how are they serving like hundreds of thousands of users with 1
exactly.
million contexts? Like, it's quite interesting. So yeah, I mean, I don't know. There are a lot of interesting topics to cover, and like the goal of InferenceX, I think, uh, both of us have this like policy where we just want to make the most real world benchmark possible, and we don't want to force people to use certain uh, optimizations, and we just want to showcase like the optimal Pareto frontier. So whether that's using AFD or like KV cache offloading, like we just want to show it in the most honest way possible. But yeah, I think that about wraps up, unless you have anything else to say.
Yeah,
So
that's it.
I think anyone listening to this podcast should definitely check out InferenceX.com to see all
Yes.
these results for free. Beautiful visualization. We got a great front end developer, Alec. Shout out, Alec.
Yeah.
And yeah, that's it. Thanks for talking, Bryan.
Thank
Appreciate it.